Welcome to this second video. We look today at aldol condensation. Now, aldol condensation is a reaction that involves two carbonyls reacting together to give a product which is beta hydroxy carbonyl. That means it has a hydroxide group at the beta position to the carbonyl. So the two carbonyls can either be an aldehyde and another aldehyde, and the two can be similar or different. The carbonyls can also have an aldehyde and a ketone, and then we can also have ketone and another ketone. But the two ketones can also be similar or different. Now, when we are using two similar carbonyls, that is now the normal aldol condensation. But when we are using any two different carbonyls, that is two aldehydes which are different, or an aldehyde and a ketone, that is what we call crossed aldol condensation. So we can have crossed aldol, and we can have the normal aldol condensation. But again, we need to note something, that at least one carbonyl must provide a second site reaction for aldol condensation to take place. That means we cannot use an aldehyde, two aldehydes which have just one carbon, that is formaldehyde. We cannot just use formaldehyde, because if we have formaldehyde like this, and this is hydrogen and this is hydrogen, there is no second site of reaction, because second site of reaction is at the alpha position to the carbon. So the carbon at the alpha position is the second site of reaction. So an example is when we have something like acetaldehyde. We have carbon here, and then we have hydrogen here, and then we have oxygen here. So we can have acetaldehyde. Or when we have something like propanone, that has two second site reactions, like this one, where we have two. If we have these are representing carbon chains, then it has two sites, second sites. Now, the steps involved in preparation of aldol product. The very first step involves preparation of carbanion. And if you followed the first video on ketoenol tautomerism, can remember how we were converting a carbonyl to a carbanion. So the step can take place either in presence of acid or in presence of the base, or what we call acid catalysis or base catalysis. So you can check that back on that video. Then the second step involves the carbanion that we have produced in step 1 attacking the carbonyl using the second site of reaction. So if we have the carbanion, the second site must be negatively charged. That is, we can have something like this. We can have R here, and then here we make it negative. So R can be either hydrogen, or it can be a long chain. Maybe it can be carbon or another long chain. So this site, second site, it is at alpha position from the carbonyl carbon. It attacks the other carbonyl carbon at this position, like this. So, but this, remember, this position is somehow positive because of the electronegativities of carbon and oxygen. So these electrons shared here are drawn more towards the oxygen than towards the carbon. Therefore, this acts as the nucleophile, and this one acts as our electrophile. And then when this is attacked, this one opens up like this, and another series of reaction takes place, because this one now becomes negative. That takes us to the third point here, that oxygen of the carbonyl abstracts a proton. So it can abstract a proton from the medium of the reaction, which can be water. In case we are using base catalysis, water is an excellent medium that can provide a proton. So when it abstracts a proton, the product becomes beta hydroxy carbonyl, which is now the true aldol product. Then at that point we can say that complete aldol condensation has taken place, although the reaction may continue to the fourth step, where now the hydroxy group which has been produced here can be lost, or it leaves by dehydration to form alpha beta unsaturated compound, which now marks the end, that the reaction cannot continue from that point. Let us briefly see the mechanism of the reaction. So in this case we are using propanone. We are starting with propanone, and the first step involves the preparation of a carbanion. So to prepare a carbanion from this propanone, since this is carbonyl carbon, the second site has two second sites here. Any of them can lose a hydrogen to a base. Let us use base catalysis. So if we have OH here, it can abstract a proton from here. Maybe we can have this proton here, and then it will abstract it like this, and then this bond will break into this, and this bond will open up to form this byproduct here. So this product can still rearrange itself by this negative, the electrons here coming down here, and these ones coming up to that point, so that we form our carbanion. So this is propanion, which is our carbanion, like that. Then at the second step, the carbanion that we have produced here now abstracts the carbonyl using the second site. So this is the second site at the alpha position. It attacks the carbonyl carbon, and this opens up like this. And remember now, this is position, for example, position 1, it joins here at position 2. So if we can name this as position 1 and this as 2, this becomes position 3. Then we can have our position 1 here, and position 2 here, and maybe our position 3 here. And this, if we label it as R prime, it will be this one, R prime here. So this is a new bond that has been formed. So it is a characteristic of aldol condensation. So, but now the product, again we said it abstracts, in the third step, it abstracts a proton from water. So water is an excellent medium to provide a proton. So it abstracts a proton like this to form the hydroxy. But the hydroxy is at beta position from the carbonyl. So this is carbonyl alpha beta. And this is now the product we are calling beta hydroxy carbonyl. So this is now the true aldol product, although the reaction may continue to the fourth step, where now if we hit this product here, the hydroxy group becomes a living group, or it leaves upon heating, and this bond breaks into this one, forming another pi bond between the alpha and the beta positions of the product, and therefore we have alpha beta unsaturated carbonyl. Remember here we are supposed to have a carbonyl oxygen here. So the product becomes alpha beta unsaturated carbonyl. carbonyl. So that is aldol condensation, and thank you for following us through all this video. If you have any comment at any point, you can please give it so that we get feedback on how we can improve, and we'll be very happy. Please also remember to subscribe and also like and share the video. Thank you very much.